Hello everyone and welcome to our webinar covering the latest release of EMWORKS flagship MotorWizard software for electric motor design. My name is Sumit Singh, working as a product manager for e-motor simulation, and I will be your presenter for today. We have been looking forward to this MotorWizard 2024 launch for a long time, as it includes some major enhancements and new features that take the software to the next level. This release is a culmination of years of research, development efforts, and invaluable feedback from customers like yourselves in the motor design community. To kick things off, I will provide an overview of what MotorWizard is and its core capabilities for those who may be new to the software. Then, we will dive into what's new in MotorWizard 2024, covering the major upgrades. Finally, we will put MotorWizard 2024 through its pace with a live software demo so you can see some of these powerful new features in action. For those unfamiliar, MotorWizard from EMWORKS is a comprehensive template-based electromagnetic simulation solution tailored specifically for electric motor design and analysis. It combines an intuitive design front-end with embedded finite element analysis solvers for virtual prototype designs. One of its biggest strengths is flexibility. It offers a diverse range of templates for surface-mounted PM motor, interior permanent magnet motor, with inner rotor and outer rotor topologies for PMSM and BLDC types of motors. MotorWizard supports both automatic and manual winding pattern generation with versatile slot pole combinations. And it includes an extensive built-in library with property data for a wide range of electromagnetic materials. But where it shines is the integration of high-fidelity 2D transient and magnetostatic finite element solvers with automated meshing and boundary condition setup. This allows you to simulate detailed electromagnetic fields and compute critical performance parameters quickly and accurately. Some key outputs you can analyze include torque characteristics, power, losses separated by type, terminal voltages and currents, flux linkages, inductance, and even force and vibrations. Ultimately, MotorWizard helps reduce time to market and overall costs for new motor designs by streamlining and accelerating the entire design prototype test cycle. So with that background on MotorWizard's core capabilities, let's turn our attention to what's new in the MotorWizard 2024 release. As I mentioned, we have made major upgrades across various fundamental areas. First, we have integrated a new CAD engine powered by Autodesk Inventor to provide enhanced 2D and 3D geometry modeling and editing capabilities right within MotorWizard. Second, we have focused on raw computation performance, accelerating the embedded FEA solvers with support for concurrent multi-computations and more accurate periodic boundary conditions. Third, we have completely overhauled the graphical user interface that elevates the user experience for more efficient workflows. And finally, we redeveloped the post-processing result center with new visualization and data analysis tools to streamline how you interact with simulation results. Let's drill into each of these features in more detail. One of the most frequently requested enhancements we received was for more advanced geometry handling capabilities within MotorWizard. Previously, geometry editing was fairly limited in scope. Well, I'm excited to say that we have addressed this by integrating MotorWizard seamlessly with the powerful CAD engine and modeling toolsets from Autodesk Inventor. What this means is that you now have access to Inventor's full-fledged geometry modeling workspace right within the familiar MotorWizard environment. You can take advantage of Inventor's industry-leading parametric modeling tools to precisely manipulate and edit the geometry of your motor designs. This includes the ability to push or pull faces, to extend features, add holes of various shapes and size, apply fillet, create additional cuts, and so much more. By leveraging Inventor's robust CAD kernel, MotorWizard now provides an unprecedented level of control and flexibility for creating any custom geometry, going far beyond what was possible in previous versions. This will empower motor designers to explore even more unique, specialized designs tailored to specific application requirements or packaging constraints. Next up are the major enhancements we have made to MotorWizard's competition engine, starting with leveraging simultaneous solves for concurrent multi-computations. Now, MotorWizard can take full advantage of modern multi-core CPUs. It can distribute simulation workloads across various cores and threads. What this means is that you can run multiple competition jobs simultaneously for a huge boost in overall throughput. So instead of waiting for a long transient simulation to complete before moving on, you can kick off additional analysis concurrently, whether that's a different parametric variant or a new design iteration. This ability to pipeline and parallelize computation workloads will significantly accelerate design exploration and optimization cycles. In addition to speed improvements, we have also focused on enhancing solver accuracy. We achieved this by implementing periodic boundary conditions within our FEA solvers. For geometries with multiple periodic regions, this allows us to model just a single periodic sections rather than the entire motor assembly. The efficiency gained by simulating a smaller region combined with the mathematical mapping of periodic constraints results in much faster solve times without sacrificing accuracy compared to conventional modeling of the full geometry. Shifting gears to the user interface. MotorWizard 2024 received a complete facelift with all new graphics UI designed for an intuitive user experience. We redesigned the entire layout and workflow. The goal was to consolidate features in a logical way that promotes efficiency. The MotorWizard Manager now surfaces all the key parameters and settings you need in a single unified panel. Within this manager, we have reorganized settings into rational groupings like stator, rotor, windings, and materials. Each section compactly displays just the essential properties, with the ability to easily expand for more advanced options. But beyond just looking great, the new UI is fundamentally designed around simplifying and accelerating MotorWizard's core workflows. From initial design geometry creation to specifying materials and winding parameters to visualizing simulation results. Speaking of simulation results, our major area of enhancement is the all-new Results Center, where you view, analyze, and manage all your post-processed data. The first thing you will notice is the modern, uncluttered layout with customizable docking panels. This allows you to configure the workspace to best suit your preferences and analysis needs. We have also redesigned the main data view to be more visual and intuitive, using the spreadsheet for a more dynamic table visualization. This makes it easier to scan and compare values across iterations, designs, or simulation. Of course, you still have access to sort, filter, and manipulate data in familiar spreadsheet-like actions. In addition to performance parameters like torque, power losses, and currents, The new result center can also visualize detailed electromagnetic field quantities like flux densities in contour plot, vector plot, and many more. Animation support also allows you to scroll through transient results over time. One of the most powerful new capabilities is the direct integration of data processing tools within the new result center itself. You can now apply functions, regression analysis, predictive analytics, and more without having to export data to external tools. And by leveraging MotorWizard's new CAD engine integration, the updated result centers provides access to convenient geometry visualization and measurement tools. So you can inspect the geometric parameters, identify areas of interest, and correlate back to computed electromagnetic performance data, all within the same synchronized environment. With an overview of the major features out of the way, let's take a quick look at where you will find all these enhancements within the updated MotorWizard 2024 interface. On the left hand side, we have the project tree panel, which provides a centralized way to manage all your projects, design, and associated simulation datasets. You can create multiple project nodes to separate out different motor programs or product lines you may be working on. Under each project, you can then create any number of sub-design entries. These design entries could represent geometric variants, material, or winding configuration options, different operating conditions, or really any permutation you want to explore and compare. For each design entry, MotorWizard automatically manages and stores all the related simulation data, results, visualizations, and more in a conventional folder hierarchy. This multi-level organization makes it easy to work on different motor variants concurrently, while keeping everything traceable and well structured within the project tree. The main new window is where you'll be doing the core design and geometry modeling work in MotorWizard. This area provides multiple viewing modes. The default view shows a fully shaded, realistic rendered 2D and 3D preview of your complete motor design. This live preview updates in real time as you're making changes to geometry, material, or winding parameters. You can also toggle to view the stator core or just the rotor core, or isolate the winding views to focus on slot pole combinations and winding layouts. Having these filtered viewing modes make it easier to visualize and inspect specific regions of interest. Over on the right hand side of the MotorWizard Manager panel, this is your one-stop shop for accessing all the key design settings and tools. Within the manager, settings are logically grouped into sections like stator, where you define the stator core geometry and slot parameters, rotor, covering the rotor geometry, magnet, air gaps, and so on. Winding is for defining your stator winding layout, conductors, insulations, and connection patterns, and of course materials for the full electromagnetic property library. Having all these frequently used settings consolidated into a single unified panel organized by functional area really streamlines the overall design. Moving ahead, next we have now the power of Direct Geo Editor tool available within MotorWizard. This gives you full access to editing capabilities but tailored specifically for motor design workflows. You can make direct edits to the 2D motor geometry models, with edits previewing in real time as you're making them. This includes changing magnet thickness, slot area, back iron thickness, slot opening, magnet angles, and much more. Of course, the embedded MotorWizard intelligence automatically updates related parameters like slot areas, winding layouts, and material specifications anytime the geometry changes. Overall, This new Direct Geo editor brings MotorWizard's geometry handling and 2D modeling capabilities to a whole new level for ultimate design flexibility. Moving ahead, another area I wanted to briefly cover is the Material Center. We have significantly expanded MotorWizard's built-in material library database. You now have access to an even more extensive set of both linear and non-linear magnetic material, property data spanning electrical steels, magnet materials like NdFeB, Samarian cobalt, ferrites, and alnico, as well as copper and aluminum winding conductor data. Having this broad library of predefined, verified materials helps accelerate the design phase by quickly getting accurate BH curves and properties into your models. Of course, you can still fully customize materials as needed by importing your own data files or creating new material. Let's transition now to the area where you will be spending a lot of time analyzing and processing simulation results, the new Result Center. We have added the spreadsheet for a more visual, focused presentation optimized for multi-parameters comparisons across designs or iterations. You can easily customize the layout and formatting of these tables by showing, hiding different output columns of interest. And all the familiar spreadsheet like data sorting, filtering, and manipulation tools you're used to are still there. One powerful new addition is the ability to apply functions, regressions, and other analytics directly to results within the data table itself. So you can now perform analysis and derive higher level metrics without having to export data. Alongside the panels, you will find visualizations of scalar and vector field quantities mapped directly onto the 3D motor geometry. You can use these to inspect things like flux densities, flux linkages, current densities, and many more. These visualizations panels are fully animated to transient simulations as well. So you can simply scrub through time using the built-in animation controls to see how fields evolve over an electrical cycle. The visualizations are also interactive. You can pan, zoom, rotate, and even take accurate measurements of geometric entities or quantitative values right within the 2D view. To better illustrate how all these new features come together in MotorWizard 2024, let's go ahead and transition into a live software demo. I'll be working through some examples to highlight the new UI workflows, geometry editing with direct modeling, simulation setup, and analysis in the Result Center. To start with, let's create new projects in Project Tree. We save the name of the project and launch the BLDC motor design. In addition, we will also see we can create multiple designs with different types of analysis such as on load, no load, performance analysis, etc. Next, configure model settings using MotorWizard Manager and enter parameters like current, voltage, speed, as well as number of slots and poles and phases. Next comes the stator setting, where we enter the outer and inner diameters of the model, choose the type of slot, and edit its parameter using either table inputs or of course directly using the geometry editor feature. Similarly, we have for the rotor setting, we choose the type of rotor, edit its parameter, again using either the table inputs or directly using the geometry editor feature. Next is the winding setting for distributed and concentrated windings. We can enter the coil properties such as the number of turns, its insulation thickness, and other many parameters. Finally comes the material setting. We can create and customize our own project library, and also we can edit the material properties as per the requirements. Once the geometry is set, we can create different analysis and adjust using the MotorWizard manager. In the analysis setting, we can enter the number of steps, number of simultaneous solves, advanced angles. We can choose whether we want to add any sort of eccentricity to the model, whether it's a static, dynamic, or mixed. We can also choose whether we want to add any kind of linear skew to the geometry. Once we have done with adjusting the settings using the MotorWizard manager, and now we can hit the run button. Once the simulation is completed, we can view results like torque, losses, etc. in the result center. We can also visualize fields on motor geometry, creating animations and applying functions to analyze results. As you can see from the demo, MotorWizard 2024 really does set a new benchmark for electric motor design. Virtual prototyping and analysis through its enhanced modeling, accelerated solve performance, intuitive visualization, and integrated toolsets. That brings us to the end of today's webinar. I would like to sincerely thank all of you for taking the time to join us. We really appreciate you being here to learn more about the latest MotorWizard release. So once again, thank you for your time today and your continued support to EMWORKS. We look forward to working closely with you to push the boundaries of electric motor innovation.